How you going, champions? It's been a long time since I've done a video. It's been another month. All sorts of shit's gone on in the last month. Regional travel opened up again. Restrictions eased a bit. So we were sort of gallivanting around, having a good time. Still doing a shit ton of work, but yeah, this one took a while to get approved. The guy took a while to get the money together for the full works burger. I gave him a few options. It had 120 volt mains. One of the options was let's convert it to 240. The transformer in there was only capable of taking 120. It's not a universal transformer, so we couldn't rewire it or anything like that. So the only option was a transformer replacement. So we ordered one, and it took a while to get here. Everything's taken a while to get here at the moment, as I'm sure you all know. It's coming into Christmas, so we've got the postal system pretty much at its real limit, plus all the pandemic-y stuff. So yeah, we eventually got this thing here, big chunky bastard. It's a Hammond 290 AEX. So that's the universal replacement or 240 volt replacement for, well, it can take 120 as well. It's universal replacement for various fenders in this sort of setup. It does the Champ, the Vibro Champ, I think the Bronco, all sorts of amps in that power range. So yeah, we're gonna remove this plug and cord as well, because that's the US style. Little choo-choo there. And put a Aussie one on, molded plug, modern. It's got the safety pins, so if anything falls down, if it's not fully plugged in, it won't, like a guitar string or something won't go live. So we're going to put one of them on, but we'll set that aside for now. We don't need to work on it with a cord hanging off it. In fact, we'll cut this one off because it's getting annoying. It's one of those old natural rubber cords, like vulcanized rubber. It's got sort of a matte sort of finish to it, and old school. I like to find a good place to get proper rubber cords. The PVC stuff, it's flexible, like it's not bad. It's pretty, you know, not that annoying to use, but it just doesn't. It just looks cheap. I want to get the nice vulcanized rubber cords, but I haven't found a reliable source of them without it being like medical instrumentation supplies where they charge you like $600 for a certified power lead. We're not doing that. So the plan with this, if you remember from the previous video, this is part 2. There was a part 1 where we went over the thing and had a look and diagnosed it, and the caps were dying like flies while we had the camera on it. We could see various sections of this this cap going open circuit, so becoming not a capacitor anymore. So we're going to disuse this capacitor, the chassis mounted one, and we are going to do a little trick which I like doing. So this tag strip here, its only purpose is holding the connection for the neutral in the US style wiring scheme. White is neutral, black is active. So black goes to the fuse tip as it should, then goes to the switch on the front panel, and then goes to the transformer. And the neutral is just literally comes straight in, goes straight to the tag strip there. That used to be a ground. So what we're going to do is remove this. So I'll just cut that straight off, and we're going to unscrew this tag strip. You can see there the screw. And we'll see how strong these soldered grounds are that everyone seems to defend. Oh, look at that, fell straight off. Maybe it's almost like we shouldn't use solder in addition to a screw and use that for your main ground. So same goes with the transformer hardware grounds. Not a good idea. Every time I take one of these off, it seems to just fall off. This one looks a bit better than your average one. But yeah, it's not a reliable way of mounting stuff. I'm going to clean up that solder. I'm going to fold over these leads like so. Get them out of the way on that useless cap. It's only a couple of years old, it's already stuffed. Not even a couple, what is it? Probably 2017, yeah, a couple of years old, it's already buggered. So we won't even entertain the idea of using another multi-section for this amp. The only multi-sections I really like using are the F&Ts for Marshalls, you know, the 32 plus 32s or the 50/50s. They're fine, I've never had a problem with them. These multi-sections from JJ's or CE, they always seem to have a fair bit of problems, so I try to avoid it if I can. Now, of course, the classic Fenders all utilize that, so we have to come up with another way of doing it without drilling holes in the chassis, without modifying it too heavily. Look, if it's a collector amp and it still needs to be turned on, you could use one of those multi-sections that are freely available at the moment, but I wouldn't be using it for a gigging amp, basically, unless you had a backup amp or something like that. So what we want to rely on is these here. So F&Ts, we've got two 22s and a 47. Where was I? Yeah, so I like to use these axials and I mount a little tag strip in there, like so. So this is your average tag strip. It's just you know, phenolic board with the contacts riveted on and a few mounting points there. So if you get one of them and you bend the legs out like that, just twist them a bit. Be careful not to screw up the rivets and pull them out. I mean, they're holding on by a fair bit, but you can get those hole centers aligned just. And these holes, this is a CBS era Fender, these holes that are pre-existing in the chassis, we can pump a screw through them with some lock washers underneath to bite it into the chassis. That will provide our ground. We'll put some bus wire through it, and that whole thing will be the ground bus for all those caps. We'll just mount them literally to the node they have to go, crossways over that existing cap, and that'll be our new filter network. Fully sick, bro. So let's get to work, eh? We've got to remove all the secondaries on that transformer because we're replacing it. We'll give it back to him. He can hang on to it along with the amp. You know, keep it with the amp. Now, if you remember from the last one, there was a bit of a horrible distortion happening in this thing too, so we'll do all the grunt work and then we'll investigate that. It could have been another symptom of the caps, could have been coupling between stages or motorboating oscillation. It didn't sound like oscillation. I don't think I had the scope attached at the time, but if it's still there when we have done all the other work, we'll investigate further. So a big problem with a lot of tech work I've seen by other people is they don't have a second soldering iron that's capable of producing enough heat to reliably solder to a chassis. So The camera's not focusing. Oh yeah, another thing I'm gonna have to buy a new one of. So we've got a big ass soldering iron that's single purpose, is to solder 2 chassis. So I don't expect that of my pace. Just use my my cable retainer pliers there. That's something I didn't think I'd need. Battled on for years without one, and when I bought one I was like, why the hell didn't I buy this $14 tool about 10 years ago? It's just so easy to put them in and out now. I used to stuff around with pliers and multi-grips and all sorts of shit before, but yeah, once you get a pair of them you don't go back. They're YTH205s. They're just generic, you find them everywhere, eBay, you know, Amazon, whatever. Evil Amazon. Gonna remove the fuse because that is 1 amp, which is correct for 125 volt, but we're going to be putting it on 240 volts, so it's the same amount of power, which means less current. So we'll put a 500 milliamp fuse on there. Alright, that's a screen node. Preamp node. Yeah, wire's holding on by a strand. We'll check those resistors for drift as well. Their carbon composition known to drift significantly, particularly in high demand areas where they warm up quite a bit. 1.5k. There you go, you can read that there, eh? So it's a 1k resistor drifted by 50%. So that's coming out. 10k resistor drifted by 12%. So it's borderline, but I think we'll replace that as well. Probably can't test the oh yeah, so the cathode resistors drifted 488. Used to be 470. That's probably within tolerance. Not the end of the world. 68 is 66, so that's actually a little low. 0.9 meg, that's within tolerance. So generally it's the resistors that are in a high load area, where they're taken pretty close to their power level limit. They are the ones that will drift. I don't know the exact science behind it, but I'd imagine it's being carbon composition. It's basically just conductive shit in a clay that they just squish together. I guess thermal expansion and shrinkage would put tiny little cracks between the grains of the conglomerate, whatever the hell you want to call it, and that would increase the resistance over time. I guess that's it. It also, they absorb moisture and all sorts of stuff because it is porous. It's got an epoxy on the outside, but you know, when something's been warming up and cooling down a million times a lifetime, that's what happens. 100k is pretty well within tolerance. 101k, they're the plate loads. 101k, so they're all pretty good. So they're all not far off except for in the power stages, the power supply, sorry. Now there's a bit of arguments as to what type of resistor to use where. A lot of guys are advocates for carbon comps on the plate loads and some of the tone circuits. I'm not that fussed, but I mean, I do know they do have non-linearities at high voltage, so that would make sense with high voltage swings when it's you know, reaching close to the limit of the plate voltage, I guess it would have some sort of compression. Looking at the non-linearity curves of the carbon comp resistors, so you know, there's probably some merit to that. In this case, we're only using we're using the existing plate loads anyway, so whatever. But for the power supply, there's no significant swing to it, or there shouldn't be if your caps are in good condition. So I think we'll just use Y-wounds there, yeah, or metal film. You can use pretty much anything in the power supply: metal film, carbon film, metal, bloody carbon comp, whatever. I don't use carbon comp because they do drift a lot. I tend to go for metal film in lower power ratings, and then Y-wound for higher power ratings. So just getting rid of a bit of that wax in that area. It can become conductive as well. Give it a few cycles of just heating up. Got the hot air gun at 200 degrees C. Just it'll help drive off any moisture too, and then we'll use a bit of alcohol in the area. Bit of cotton bud. Leakage in this area is not the biggest issue because it's just the power supply end. Down the other end it can cause all sorts of weird behaviour. I'll grab some 3-watt metal films I've got. Don't want to overdo it in this area. If you put like a 10-watt cap in there, resistor in there, it won't act like a fuse if something goes seriously wrong. I mean, ideally you don't want to rely on a resistor as a fuse anyway, you want to rely on a fuse as a fuse. But it's sort of like the last line of defence in amps that don't have any secondary fusing. See, a lot of wax just came back out of that board, just from heating up that eyelet. So you think you've removed all the wax. Wax off, wax on, then you heat up the eyelet, and it all comes out of the board, because it's just all through it. A bit of heat and alcohol drives it out, or helps too anyway. I think we get out the big Mamba Jamba soldering iron, start putting some eyelets in, tag strips in, and we'll get rid of these eyelets on the transformer mounting bolt holes, and we'll mount them just straight to the chassis. So I'll get out the big ass soldering iron if I can find it. YouTube, meet big ass soldering iron. Now where are we going to plug it in? That's the next question. We've run out of PowerPoints. I'll plug it in where the laptop's plugged in, because laptops have batteries. Alright. So this thing's not temperature controlled, it just keeps getting hotter and hotter and hotter. So it gets to a certain point where the flux instantly evaporates and you got to turn it off and use it. And then if it cools down too much, you turn it on again. But generally you're using it for 1 or 2 joints and just to clean up stuff. So you turn it on until it warms up, use it, turn it off. So I'll just nip these buggers about there so they just slip down through the eyelet. Leave about 3 mil of height on them. 1/8 of an inch for you Yanks. There you go, so we've got the 1K for the screen node. Got the 10K for the preamp node. Sit all hunky-dory in there. Just put a dab of solder on there. Don't want to fill the eyelet because we've got to fit wires in there later. Just so they get held in place. have to get something down into the eyelet to just clear a path for the wire that you're going to put through. If all the wires are going crossways through the hole, you can't fit the wire down in after. Not a big fan of eyelets myself. Prefer turrets, or ideally circuit boards. I know, shock horror. Right, so where are we with the soldering iron now? Just warming up. It's a big tip, so there's a fair bit of inertia there. It's takes a bit to push the solder in still, so it's still a little bit cool. And it's starting to kick off. So I'll clean up the excess solder in this, using this in tandem with the solder sucker, the extractor. It heats up the chassis to the point where you can just use the extractor gun to take out the rest. So that came off really easily. It was holding on by like a tiny little bit at the end. So yeah, not a great way of having your main grounds, particularly your safety ground. So that looks like about as ideal as you're going to see a solder joint on an eyelet. And yeah, it's pretty good, but it still comes off pretty easy. And it doesn't look like there was a lot of a sort of, you know, connection there. I mean, they gobbed a lot of solder on, but what happens is that the bolt, the transformer's got mass. It rocks around, and there's no Loctite or anything on there. There's a couple of star washers, but they don't do a hell of a lot for big bolts, really. They're more suited to like M4 and below. They don't do a hell of a lot when there's a lot of mass involved. And you get a bit of a break between the chassis and solder joint, and not a reliable ground, and you get hums and all weird stuff, or just unsafe, an unsafe amp. Alright, now that looks friggin' horrible. And that's that 50-year-old flux. So we'll grab some alcohol and show you that it actually cleans up pretty good. Still a bit warm. That's not too bad. Doesn't disappear, but of course the plating's been affected, and there's still a tiny bit of solder film on the top of the plating there, but looks presentable. Looks nice and clean. Ready for the transformer bolt to go back in with no terminals on it. So we're all cleaned up. I'll put this new tag strip in. We'll get some M3 screws with some lock washers. We'll drive the screw in from the outside, and I don't like using the self tappers on this, especially where it's going to be a grounded connection. So I'll get some M3, maybe M4. Let's have a look. A couple of M3 screws, some nylock washers, and some star washers. Right. Let's check which way around we want to be for the cap length. We won't have them swinging around in the breeze if we don't have to. So there's miles there, so we'll turn it around this way. And we'll go the 47 on the screen node, because we can't hit the 5Y3 with 47 microfarads. It'll short it out over time. We'll go 22 as the B plus node. We'll go 47 as the screen grid, and then another 22 on the preamp. We want to go screw, lock washer, and then tag strip, another lock washer, no lock nut. Same goes on the other end, screw, lock washer, star lock washer, internal star lock washer, external, whatever floats your boat. Another lock washer on the top of the tag strip, no lock nut. So that's our mounting point for those caps. We'll run a bus wire through them. That's also our ground connection. Right, so that is our ground bus. We've soldered them to each tag, and that's a convenient point for grounding whatever you want to ground. So now we'll mount the axials. Too much lead length on that one, we'll trim a bit off. That's the transformer, output transformer. We'll connect the screen grid. I'll just shove that in for now. Got to put the cap in there as well. We'll go our first 22, what am I trying to say, 22 microfarad. Straight into that eyelet there, and sort of center it between where it's going and the eyelet. Fold that lead over, cut off, leave about 1/8 of an inch on, fold that back over the terminal. There we go. So that just about holds on by itself before we even solder it, and that's what you want. B plus node cap installed on the screen grid. Now I like to do this with the specs of the cap facing upwards, so the next tech or whoever inspects the amp can see what has been done to it, what the values are, where they are. Some guys like to put a date that the caps were changed for the next tech. I'm not a charity, man. Figure it out yourself. No one does it for me, so screw them. So we've got all our caps installed. Now we've just got to install our transformer. So let's look at that. What I like to do with these ones is put a bit of tape on them because it's nice and shiny, it's got the logo there, and as much as you try and clean your bench, there's always some gritty crap on there that scratches the bell housing, so just grab a bit of 50mm masking tape. So I'm just tightening up these nuts. They've got nylon washers, so don't go crazy tightening up these things. They do sandwich the laminations together, so you don't want them loose, but if you tighten them too much, they squash the nylon, poo out the nylon coating, nylon washer. Alright, so we'll put the primaries on one side so we can cable tie them up out of the way. So we only need what we need there. and the secondaries can be closer to the circuit, so we can keep the wires nice and short. A lot of people, a lot of other techs I've seen like to leave all that wire floating around in the chassis. That's retarded, in my opinion. It's like they think they might use the tranny for something else at some point, but then you've got all these stray magnetic field, electric fields set up by those excess wires floating around in the chassis. So this transformer is significantly taller than the last one. Playing some jazz next door, that's cool. Playing Bon Jovi yesterday, I prefer jazz. So I've got a new bypass cap for the 6V6 in there. I'm putting a new 470 ohm cathode resistor in there. The stock one was 2 watt carbon comp. This is 5 watt wire wound. It's even smaller. It just allows it. I could probably put a 2 watt in there, but the larger resistor body just gives it a greater surface area to dissipate heat, so things don't get crazy hot. Just bend the leads a little. We're trying to space it away from the bypass cap so the heat will affect it less, and we put the bypass cap on the side away from the dropper resistors. If you can, try and put any capacitors away from any heat sources, and they'll thank you with a long life. A lot of manufacturers should probably start thinking about doing that if they want their products to last. But they don't, do they? So the amount of amps that I see where the caps are like hugging a heatsink, like it's like they literally couldn't get them any closer. Like they almost, like you may as well cable tie the friggin' things to the heat source, and then they wonder why they fail. Well, the name of the game is to get you to buy a new amp, so mission successful. Now, one thing to bear in mind, one of the reasons I replaced this cathode cap on the 6V6 is because that resistor, the cathode resistor, had drifted. Now, as that value of that resistor increases, even worse if it goes open circuit, then your bypass cap gets exposed to high voltage and it can damage it. It may not fail immediately, but it'll weaken it and could change its value and characteristics. So for the sake of a $2 cap, let's just change it out, and put a Nichicon in there. 50 volter, so there's a bit more margin if something happens again. But like a shorted valve, for example, a shorted valve can take out the bypass cap. So it's one less thing we have to second guess if we have any issues when we power it up for the first time. So here I'm just twisting the 5 volt heater lines. They just go straight to the rectifier valve. You know what? I was about to start soldering stuff to these valve sockets, but on second thoughts, I think I'll replace them. These are those real shitty brown Bakelite things with an M written on them. I don't know if that's Mallory or whoever made them at the time. The biggest issue with them is, well, besides the fact the contacts are corroded, they don't make contact very reliably. So look at the angle, that's probably 45 degrees, and you still can't see the contacts. They're like 4 or 5 millimeters down in the hole. Now, I don't know if that was done for safety reasons, but it makes for a very unreliable contact to the valve and almost no mechanical support to the valves that are hanging upside down. These don't have any retainers, so literally you're only relying on the valve tension, the pin contact tension, to hold the valve in a vibrating combo. Let me just show you. It's kind of hard to make out, but put the valve in, literally one finger No satisfying, you know, scritch as it goes in or anything. 2 fingers and it falls out. Like you barely pull it about one or 2 mil, and it just comes out. You could probably retension them. See, it only starts to bite about there, and it's just like almost no tension on them. So I think they can come out, and I'll put some Beltons in there. Originality be damned. I'm not sure what brand they were, but yeah, they got a little M on there. It's kind of hard to make out just there, and they're that poo brown. So we'll replace them with some Beltons, I think, and some retainers. Alright, so you can see the difference. So here's the old socket, I just removed it. It sort of starts to bite at about I'll say 3 mil left of the pin. So it only starts to sort of grab there. This is the new Belton. It's probably got over 1/4 of an inch, but like I can't push that in with just like 2 fingers. And they're, oh Jesus, there it goes across the room. They're the kind of contacts that self-clean the pin. Every time you plug it into it, sort of scrapes the pin a little bit as it goes in. Not like, it doesn't remove any metal, but it just wipes off any corrosion or anything as you put it in. A little bit like the speak-on connectors for speakers. I'll just remove the old socket. I've already done the rectifier socket. Now the difference with these, the Beltons have a little collar on them. So technically the hole should be bigger for them, but this portion down here is the same diameter as the old socket. So it sits up about, I don't know, 2 millimeters. It's still secure. You can see the bracket on this one's offset. On this one, the lip stops it from going all the way in. I could drill them out. I don't really want to. I don't want to go drilling massive holes in chassis. I want to try and keep it, you know, original, where we can have a little workaround that doesn't have any drawbacks. So that's what we'll do. We'll put the socket in, the keyway towards the back. It's a pretty tight fit. It sort of sits where you leave it. Put the socket in, keyway towards the back, and then just slide in 2 little flat washers. Sounds like Dave Brubeck next door. Very, very jazzy morning in the cabinet making shop next door. And there we have it, 2 new sockets. So now I've just got to wire them up. So that's 2 new sockets in there. We've just disconnected all the wires. We'll check that we can reuse exactly how they are, otherwise we'll strip them back a little bit and expose some new fresh wire. Alright, so that's the output valve 6v6 socket and the rectifier socket wired up. Now the Beltons were a slightly different sort of angle to the terminals than the original one, so some of the wires had to be replaced. This red one, for example, the white one that was there was sort of where this terminal was, but the Belton socket's got a slightly different sort of, the terminals are sort of pointing the other way when you fold them over, so some had to be shortened, some had to be extended or replaced, but yeah, it's much nicer sockets. Probably good for another 20 years or plus, or more, or plus, something. Alright, so this is how I like to terminate the unused wires. Just fold them over on themselves, put a bit of heat shrink over that, then shrink the heat shrink. Sort of anchors itself on there, It can't slip off because the end of the wire is sort of like a little anchor shape. It'll hold on to the heat shrink once it's shrunk. Alright, so I've prepped my lead, power lead, and we've got a new little clip there. Now just beware this different panel thickness versions of this. This one's for a 1.6mm chassis, which is steel. They also make ones for 3mm. If you put the 3mm one in a 1.6, it'll flop around. If you put the 1.6 one on a 3mm, it won't anchor at all. It'll just pull back out again because it won't get past that lip. So let's feed this in. We've got our big Mamba Jamba iron heating up again. I'll leave that cable tie on there just so we can maneuver it around on the bench easier. Get these pliers again, special pliers. Grab it around the neck, and in she goes. And that's it, nice and secure. So, we've got the iron heating up. We're going to make two connections. We're going to do a ground for the heater, which is return path through the chassis to all the valve sockets. So we're going to put that back here-ish, where there's already a mark anyway. That's the one that goes to the lamp. That's the one that comes from the tranny. And we're also going to make a safety ground right about here where that previous one was, right next to the mains input. But we're not going to cut the ground wire, the earth, sorry. We're going to leave it long and we're going to wind it up. The principle being that we're going to make the active and neutral as short as possible, and if anyone trips over the lead, pulls it out of the amp, whatever, they'll let go, but the earth will still be connected enough that they'll touch the chassis. The earth will be connected to the earth, hopefully an earth leakage detector or residual current detector, an RCD, and it will trip the breaker. And at least, if it doesn't trip a breaker, say it's an old house with a fuse or something, at least the chassis will be at ground potential, earth potential still, and hopefully burn out the fuse. But you want that earth to be the last thing holding on if you pull this cable out through that hole, which shouldn't happen anyway with that support, but it's just the last gap measure. So let's get everything out of the way and we'll start getting ready to lay some solder onto the chassis. We're done. Just got to clean up that flux now, make it look a bit nicer. Get some isopropyl alcohol. Not India Pale Ale. Right, so we just trim the active and neutral. Just going to tin them. This cable's a massive overkill, but it's heavy duty, so it's not the current capability I'm looking for. It's the just a solid cable, large diameter and reasonably chunky. Right, so I've finished all the power wiring, had a bit of a clean up. What you find is when you're working on a bit of a rebuild, you end up covering your area with shit until eventually it encloses and you realise you're working in a 1 square foot space. So you gotta stop, take stock of where you're at, throw the shit in the bin, clean up, and then go again. and that's where we're at now. So all we've got left to do before firing it up and having a listen is changing the bypass caps. They look to be original, dated, if I can find the date code, '78, 32nd week of '78. So quite old. Older than my brother, and he's 5 years older than me. So we'll change them out. That's probably got something to do with that terrible distortion we were hearing and just the general thinness of the thing. So let's do that. Okie dokie, everything's done. All the bypass caps are replaced now. I've just sort of gone over everything. I did notice at some point someone's put a mid boost pull pot in there, and that resistor just parallels to the 15k to ground on the base pot. The customer didn't mention anything about that, so I'll leave it in. Didn't say they want it reversed or anything. So yeah, we're just going to double check everything and then we'll fire it up and see how we go. Alright, we'll just pop our 1/2 amp slow blow fuse in. There we go. Turn the variac all the way down, fire it up. Power switch on. 4 volts, 4.6 volts on the lowest setting of the variac, and it's drawing 6 watts. Bring it up. 8 watts at about 50 volts. Bear in mind the variac has an energizing power of about 6 watts. So all the way down 5.8 watts. That's with the variac sitting at what, 4.5 volts. We'll slowly bring that up. We won't see anything happen until the rectifier warms up, but at least we know our mains wiring's right. Starting to see some glow from the bulb. Flicker over to DC. Slowly seeing some conduction happening in the output stage. Plates, 200 volt. Nothing's going bang. Starting to conduct, so the voltage is going down as it loads up the tranny. 166.54, and then the preamp node 158.76. Alright, so all looks well so far. 2.5 volts on the cathode of the 6v6. We should start hearing something now if we give it. Here we go. We've got signal. Won't get any tremolo until we come pretty close to the target voltage. Oh, it's already kicking in there. So we're at 180 volts. Look, we're fine to fire that up. I just use a variac to make sure there's no shorts or wiring errors. So I'll turn the power switch off. plug her into the full 240 and let her have it. And keep an eye on the watt meter. 24 watt, 45 watt, 39 watt. It's dropping back down, 32. Now it's coming back up as we start to conduct again. 51 watt. Settling at 22 volts on the cathode. Seems a little high. We've got 385-ish. Oh, we've got the, turn the trim off. 383 B plus. 375 screen. 353 on the preamp node. 240 on V1A plate. Oh Jesus, always scares me. 245 on V1B plate. So sorry, 240 on V1A, 245 on V1B. We have the same as the screen on V2B. We've got fluctuating voltage due to the tremolo on V2A. Alright, so everything's working. Just power it down again and we'll just double check that bias figure of 22 odd volts. Right, so that's sitting at around 128, 130% dissipation on the 6V6, so that's a bit hot. So we'll just have a quick play through it. Won't keep it running forever, just to see if there's any secondary faults that we can address while we're changing that resistor out to just tone down the bias a bit. A little bit of hum. So that distortion that we had in the first video is gone. So everything sounds much happier now. Alright, so I'm pretty happy that that distortion or whatever it was going on before is gone. Likely due to the caps, but we did fix up a few things while we were in there, so it could have been any of them that addressed it. If an amp is acting weird, I don't lose sleep over what's causing it if there's a ton of other work that's got to get done first. I do like to find the exact problem if possible, but if there's like 6 other problems that, like, let's put it this way, there's no point checking for a pulse if your patient doesn't have a head. So we'll tone down that output stage and we'll have another listen and give it some signal, look at it on the scope, and then we're pretty well done. Alright, we brought that down to about 100% dissipation, which is fine for a cathode biased amp. So it was sitting at about 26.5 volts across the 680 ohm cathode resistor. We've got now 396 on the plates, so almost 400. 389 or 390 on the screens. and 365 for the preamp notes. So I'm pretty happy with that. In terms of ripple, we've got almost no hum. You've got to have your ear right up against the speaker. I've got a closed back 12-inch down here. Closed backs, they accentuate the bass, so hum is pronounced a little bit more through a closed back cabinet. When it's in its open back small 8-inch box, I think it'll be much less noticeable. But again, you've got to have your ear like 4 inches from the speaker. Not exactly a natural listening position. So the ripple on B+, it's about 3.8 volts. So that's more than it was previously, but it had 47 microfarads on the first node, which isn't good for the rectifier valve. That's acceptable. With a single-ended amp, it's always a trade-off between capacitance and if it's a valve rectified amp, it's always a trade-off between capacitance and ripple. We've got about 0.5 millivolts. When you turn the intensity of the trem up, it goes up to about 1 volt ripple. Otherwise, it's about 250 millivolts on the screen grid, and the ripple on the preamp node is down to about 20 millivolts. So happy days, it's sounding good. Let's just give it a quick go. It's at about 8. Going pretty heavily into breakup, but not farty or flabby or no weird oscillations or any strange distortion. Everything's pretty smooth. Go down to about 6, just on the verge of breakup. Crank that up a bit more. That's with bass and treble at 10. We'll go max it out. 10, 10, 10. Most of it was drawing there from the wall. It was about 48 watts. Doesn't vary much when you push it in a cathode biased amp. Alright, we'll just try the trem for a minute. It's intensity at 10, speed at 10. Bring it down to 5. Intensity at 10 still. That's the intensity at 5. Off. Duh. Go back to 10. That's the slowest speed. Intensity of 5. So just crank the volume up. Intensity maxed. Can't hear any thumping or anything. and I think we're good. Alright, so I'll put it back in its box, give it a little bit more testing, and just sit it idle for a while, make sure nothing weird happens, and then we're pretty well good to go on this one. So thanks for watching, champions. I'll try to do some more videos, share them around so it makes it worth my while. Thanks. Have a good one, eh?